This is video 3 of plate tectonics. Last time we were drawing different types of fault lines. Remember, fault lines make up plate boundaries. But again, faults can exist throughout the crust, anywhere in there. Anywhere an earthquake's going to happen is a fault. Now, the longest faults, or the longest connections of faults, are going to be plate boundaries. So anyway, we went over the normal fault, how forces, tensile forces or tension forces, are pulling rock apart. That causes one block or one section of the lithosphere to drop down. It technically makes this one go up a little bit. So this would be like the Wasatch Fault. So let's say you're living here on this plot of Earth. And say here's Jimmy. Hi, Jimmy. Hi, dudes. This is him saying hi in case you're wondering what he's doing. So if this was his house and he lived here, and this was the Wasatch Fault where we are, basically his house is getting, every time we have an earthquake, his house is kind of dropping down lower and lower in the valley, while the mountains are then almost by default rising. But they go up a little bit. But for the most part, the valley here, where we are here, is dropping. Now, reverse fault, just the opposite of a normal fault. We've got compressional forces, so instead of pulling forces, the forces are going together. That pushes these together, and if we have a 6.0 earthquake or higher, we're going to have ground rupture, which is going to create a fault scarp, and then we're going to have this land surface here. All right, let's draw ourselves strike slip fault. We're here, so strike hyphen slip fault. Now here, we're going to draw it similar to what we've done here, but we're going to have a little bit of a difference. All right, so first we're going to draw one side. I'm going to draw a basic rectangle. Now I've kind of drawn it slanty, so how I've done is I just drew a parallelogram. So if you have really struggles with drawing in perspective, all I've done is draw a parallelogram. This is parallel, that's parallel, and they're the same lengths. No big deal. I'm going to drop a line down in the corners, same length, and draw a line over. So this is one side of our block. Now we're going to show this movement of sliding action, where the plates are going to be sliding past one another. So what I'm going to have, same parallel to this, I just moved it over here. And then I'm going to have that same line projected up here. But to know where that's going to be, I'm going to finish that line there. So parallel, parallel, and then a parallel. I just drew on my kitchen table. That was not good. It's okay though. It's a crappy table. Now I want to connect these 2 points, not the one from my table, but the one on your paper. I'm going to go ahead and pretend that I connected those points. Oops, and I did. I drew on my table again. Okay, now we're going to bring down these lines like here. We're going to make some parallel lines just like these. So I'm going to drop down a line, same length as well. And then I'm going to pretend I dropped down that line, but you can do it. I'm not going to. And then I'm just going to connect my points. Now we got one weird point here. We're going to connect this one to this one and finish that diagram. Now here, if we did the rock layers the same as we did there, I did a little bit of topsoil, got little plants there, yada, yada, yada. We've got a rock layer here going around the side. Here, we usually do have a little bit of change. We do have one side going up off the other end. If we didn't, we would never see a fault scarp. It would just be strange fence posts where they shouldn't be, or orchards with the trees that are no longer lined up. Here I'm going to imply some rock layers with my dots and my stripies. There we go. All right, now here, because we have forces that are going sliding past one another, we're going to indicate that, one, with a road, so we can visually see that. And let's say our road would have not connected here, but instead it would have been a little bit here. So you can see the shifting that the plate has done. We'll say this one has moved in this direction, while this one has moved in this direction. All right, and that's all there is to it, to the strike slip fault. now back to our presentation file. We talked about some earthquake hazards. So most hazards exist due to human-made structures. So basically, if an earthquake happens, there might be a little bit of landslide danger for organisms. So that does happen. But typically when we have an earthquake, we don't have fires anywhere except for in man-made structures, because we've got things like electrical wires, we've got gas pipes, we've got places that, if broken, can ignite. So some of the things we have are building a bridge collapse. We don't tend to have huge bridges in nature, so that's, again, human. Fires from broken gas lines. We've got landslides, and if you don't know landslide, it's when the land slides. So basically, it's up high or at an angle, and it starts to come down to become level. Floods from broken levees or dams. We do have natural levees, so this does occasionally happen in nature. But, oh, I got my thing in the way. Move out of the way. It doesn't want to. There we go. We've got liquefaction. Now, liquefaction is something that you probably have never heard of. It does happen in this area, but since we have so few earthquakes, we've never really witnessed it. It's basically where sandy soils, when they're shaken, the water tends to rise up in the water table, and it will actually make the sand behave like quicksand. So it becomes sort of like a liquid.